Okay, welcome back, ladies and gentlemen. We're going to be looking at just a few extra examples for 5.2. This is just an extra video with some examples from the textbook. So let's go ahead and get started here. We're going to look at page 460 at some of your assignment problems. Obviously not the ones you need to turn in to me, but some of the other ones here. And I'm going to go ahead and start off with problem number 5. I felt it was easier to actually write down the problem than rather try to type it out. So you're going to have to bear with the writing here. Okay, so number 5 says, tell whether or not f of x, so this is, does f of x equal sine of x? Tell me if this is an identity. And what f of x is in this case is, in number 5, it's sine squared x plus cosine squared x over cosecant x. And basically it's a yes-no question, but you need to actually be able to simplify this to see if it does simplify to sine. So in the kind of what we're doing here, you're actually trying to prove this identity, and it really ends up just coming down to this. Does the left side equal that right side? Well, in this case, I'm going to use the Pythagorean identity. Sine squared plus cosine squared is 1. And then I'm going to use my reciprocal identity that knows that 1 over cosecant is sine. So that's a check mark, which means yes. All right, so that problem's not too bad. That one's not too challenging at all, especially if you've been trying some of these problems before you got to come watch this video. All right, let's jump to number 7. Same kind of question. Actually, exact same question, just different problem here. It says, all right, so now I have, does cosine of x times cotangent of x, same question, does it equal sine of x? So that's a good question. And as always, I just kind of like to look at the thing here. I don't really know what to do here, so I'm just going to change everything to cosines and sine. Well, cosine times cosine is cosine squared. That doesn't really look like it's going anywhere here. Well, let's try some Pythagorean relation identity just for the heck of it. Let's go 1 minus sine squared x over sine x. Oh, maybe some stuff will cancel here, but 1 over sine becomes cosecant, minus sine over sine is sine. Oh, that doesn't look like it simplifies at all, and in this particular case, it's not going to. So this would be a no. There's no way that left side simplifies down to sine of x. All right, now we get into the good stuff. If you've taken a look at this these textbook problems, basically problems 11 through 51 are all the good problems. They're all the prove the identity, which means, actually when it says prove the identity, that means it's able to be done. All right, so in problems 5 through 10, those are yes or no. Can you show that the left is equal to the right? No, you can't. Or yes, you can. 11 through 51, those are prove the identities, which means you actually can solve these. So starting with number 11, here we've got cosine of x times tangent of x plus sine x cotangent x. And I want to know, does this equal sine x plus cosine squared x? You notice I put this little question mark here. This is hoping to help you see that I can't cross the equal sign. So I want to know, does this equal this? We know it does, but we want to show how. So I'm just going to first start off by distributing. Well, actually, I'm not even going to start off by that. Well, yeah, let's go ahead and do that. So if I said cosine x tangent x plus sine x, cosine x, cotangent x. And still I'm looking to see, does it equal this thing on the right? The problem is now it looks a little more complicated. But let's think about the sine and cosine stuff. So tangent is sine over cosine. I'm going to do the same thing to cotangent here, which is cosine over sine. And then I like to see this. Cosine on the top, cosine on the bottom. Sine on the top, sine on the bottom. And that means I'm left here with a sine x, and here I'm left with cosine times cosine. Well, that's cosine squared. Oh, look, I'm done. That means I have sine x plus cosine squared x. All right, so using my identities there, actually all I've used is the quotient identity, really. Moving to number 14, I just kind of randomly chose some good problems. I hope I can solve them all. I didn't actually look to see if I could. But let's see what we got here. So cosine, that's not a negative. Let's undo that so I don't confuse you here. So cosine x minus sine x squared, and I want to know, does this equal 1 minus 2 sine x cosine x? It's a good question. And whenever I see things with parentheses, I usually like to get rid of parentheses. That's just me. And it's squared, so I can FOIL this, right? F-O-I-L. Don't forget how to FOIL. So if you need to write it out, I'm going to write it out up here because I don't like it to see it. I like to do it without writing it out. But if you FOILed this, you would get cosine squared x minus 2 sine x cosine x plus sine squared x. Some of you might not be able to see where we want to go here, but that's the idea, right? We got to figure these things out for ourselves here eventually. But I noticed that I have a cosine squared plus sine squared. Cosine squared plus sine squared is 1. So if I'm going to rewrite it a different way so you guys can see that. Cosine squared x plus sine squared x minus 2 sine x cosine x. Well, I know that this thing is equal to 1, so I get a 1 minus 2 sine x cosine x equals 1 minus 2 sine x cosine x, which gets a check mark and done. All right, I've shown that the left side can be simplified to the right. Going to the very next problem here. We get this. You'll end up noticing that some of these look really challenging, but they're actually not as hard as they look initially. Now, as I said a moment ago, I see parentheses, I see some multiplication going on, I like to multiply. Hopefully it always helps. I can't guarantee it always helps, but I hope it helps. If I multiply these, I already noticed that they're conjugates. Conjugates are good, which means I might get a Pythagorean identity here. So 1 times 1, and then I get a minus cosine squared x. So here, you'll want to resist the urge of doing this. This is legal. It just kind of makes your problem become this. 1 over cosine is secant. I guess you don't have to resist the urge because I just proved that this works this way. So I'll come back to this. I'll do this in a different version. Okay, you'll notice, and you'll notice that you might not solve the problem the same way the other person solves the problem. Here, I like to just look at 1 minus cosine squared is sine squared. Using my Pythagorean identity. And I know that sine squared over cosine squared is tangent squared x. Well, that's done. But since I figured it out a different way, I'm going to show you the other way as well. And this doesn't always make things easier, by the way. It just happened to be that way in this case. If I was to split this into two different fractions, 1 over cosine squared x minus cosine squared x over, oops, not sine squared, which is a legal step because I broke up the sum of a fraction, or a difference in this case. 1 over cosine is secant squared minus 1, and actually secant squared minus 1 is tangent squared x by my Pythagorean identity. So you notice there's two different ways to solve this problem, but it all started with multiplying those two things together. Let's look at number 19. Oh, by the way, you might notice on number 15 there, the variable was a u, but I like to use x, so if you want to use x, just use x. And the same thing goes for number 19 here. They're using this, which is not necessarily a b, it's actually beta, the Greek letter beta. And the question here is 1 minus sine x and 1 plus cosecant x equals 1 minus sine x plus cosecant x minus sine x cosecant x. Man, this one looks challenging. But again, don't let the looks deceive you. If I was to just, look at this, I have parentheses again. I want to get rid of parentheses, so I'm going to FOIL, and I get 1 minus sine x plus cosecant x minus sine x times cosecant x. And then I just keep looking at this as what can I do? But that would be silly because technically you already have the answer. It does equal 1 minus sine x plus cosecant x minus sine x cosecant x. Check mark, done. Look at all this extra empty space. This was kind of a, shouldn't have been unworthy to put on here. I should have skipped that one because that one's almost too easy. Not almost too easy. It is too easy. Everybody could do that with our eyes closed. Also, you notice it didn't actually require any identities. All we had to do was FOIL, and it ended up being the same thing. So let's jump down the list a little bit, down to 29. 29 looks like this. This would be the cotangent, not cosine, goofball. And you're going to have to look at these problems a little bit and just kind of figure out where to go. I'm not 100% sure where I want to go just yet. Let's try something. Hey, guess what? One of the first things to do is just try something. Well, I want to be able to get rid of this minus sign and make it multiplication. So let's think about changing cotangent into cosine over sine. I can't guarantee this is going to work, but it's worth a shot. So here I need to multiply by cosine or sine over sine. So I get cosine squared x over sine squared x minus cosine squared x sine squared x over sine squared x. Now I can combine these two things. You notice I'm going to get cosine squared minus cosine squared sine squared, which means I can factor out cosine squared x over sine squared x. And let's take one piece at a time here. Notice this, I have cosine over sine, and cosine squared over sine squared is cotangent squared. Oh, look at that. 1 minus sine squared x is a Pythagorean identity. Tells me that 1 minus sine squared x is cosine squared x, and that's what I wanted. Oh, good. I'm happy that worked, because I'm like you. Sometimes I don't really feel like doing it more than once. All right, where are we going from 29? Let's go to 37. So on 37, bear with me here as I write this down. Oops, not 2x. This is a good question here. Where do we go? So always the question is, what side is more complicated? And that's actually kind of a hard question to answer. Which one is more complicated? I believe the left one might be more complicated. So let's kind of take a look at what the left side's going to look at here, or look like here. I have something in the denominator that might be useful to multiply by the conjugate here. So let's just try that. And, oh, that's good, because that's the same thing as the numerator. That might be handy. So let's go back to red here, and I get sine squared x minus 2 sine x cosine x. See, and now already I've figured out that I don't think this is where I want to go, because I actually want this 2 sine x cosine x on the bottom. So I'm going to try something else. I've already figured out, I think I'm in the right direction here. So this is where you got to start thinking to yourself as you get going here. So let's actually multiply by, come on here, sine x plus cosine and sine x plus cosine x. So on my numerator, that makes the sine squared x minus 2, minus cosine squared x over sine squared x plus 2 sine x cosine x plus cosine squared x. And here I want to look at what I want in the denominator there. I have a sine squared plus cosine squared, which is a 1 plus 2 sine x cosine x. Well, that's good because that's kind of what I wanted. And in my numerator, I want only sines in my numerator. So let's look at my sines here. I have sine squared x minus, let's change cosine squared into sine squared. So 1 minus sine squared x. And notice here I can do minus a minus sine, so I get 2 sine squared x minus 1 over 1 plus 2 sine x cosine x. And you'll notice that by figuring out the thing that I did first was kind of incorrect. Even though it was legal, it didn't really help me. I figured out a different way to do it, and I was able to find it. All right, so here's where I'm going to pause for this time. I might make another video as well, make some harder examples. I hope you are doing these problems and actually trying them. I will see you guys later.